Every time you ask an AI a question, thousands of computer chips wake up somewhere in the world. They consume electricity, they generate heat. They need water to stay cool. And as AI becomes part of your everyday life, companies are racing to build entirely new power plants just to keep up. For decades, software felt almost weightless. You could browse the web, write a document, or send an email without ever thinking about power plants or water supplies. But AI has changed that equation in a fundamental way. The tools you use today demand resources on a scale that would have seemed absurd just 10 years ago. So why is AI different? To answer that, you first need to understand what actually happens when you type a simple question into ChatGPT. And it's nothing like the software you're used to. The difference isn't just technical, it's physical, measurable in megawatts, cooling systems, and millions of gallons of water. When you ask ChatGPT or another large language model a question, it doesn't search a database for the answer. Instead, it performs billions of mathematical calculations across an enormous neural network. Every response is generated in real time through computation. Traditional software follows a fixed set of instructions. AI works differently. It predicts what should come next by calculating probabilities based on patterns learned during training. That may sound abstract, but every one of those calculations has a physical cost. That explains why AI requires so much more computing power than traditional software. Every word the AI generates passes through hundreds of computational layers. Millions of numbers are multiplied, added, and transformed before a single sentence appears on your screen. Each operation consumes electricity, and almost all of that electricity eventually becomes heat. To do this fast enough that you get an answer in seconds, companies rely on specialized processors called GPUs. These chips are built for massive parallel computation, but they're also incredibly power-hungry. A single high-end GPU can consume as much electricity as several refrigerators running continuously. One GPU is impressive. The real story begins when you put hundreds of thousands of them together. Modern AI models run inside enormous data centers filled with racks of these chips. Some facilities consume as much electricity as a small city. And electricity isn't actually the biggest engineering challenge, heat is. Without constant cooling, the chips would quickly overheat and shut down. That's why many AI data centers use massive cooling systems, often relying on evaporated water to carry the heat away. Some consume millions of gallons every day just to keep the hardware operating safely. If those numbers still feel difficult to imagine, here's what they look like in the real world. Google's AI services alone are estimated to consume enough electricity each year to power hundreds of thousands of homes. And that's before AI search becomes standard, before every app adds an AI assistant, and before AI-generated images and videos become part of everyday life. And yes, our channel uses AI too. That's exactly why understanding its real-world costs matters. Microsoft recently announced plans to help restart the 3 Mile Island nuclear power plant to supply electricity for future AI data centers. A reactor that had been scheduled to remain offline is being brought back because demand for computing power has grown so rapidly. AI isn't just changing software, it's changing energy infrastructure. And this is where the story becomes more complicated. AI promises to help us solve some of humanity's biggest challenges. It can optimize power grids, accelerate scientific research, design better materials, and improve healthcare. But building and running these models also requires enormous amounts of electricity, cooling, and water. Unlike cryptocurrency mining, which remained optional for most people, AI is quietly becoming part of everyday life. It's built into search engines, email, smartphones, office software, and countless online services. Whether you actively choose to use it or not, the infrastructure supporting AI is rapidly becoming part of the modern world. The challenge isn't whether AI is useful, it's whether we can build enough sustainable infrastructure to support it. So where does that leave you? AI often feels like magic. You type a question into a chat window, and seconds later, an intelligent answer appears. But behind that simple interaction is an enormous physical system made of power plants, data centers, water pipes, fiber optic cables, and hundreds of thousands of specialized chips working together. The future of AI won't only be shaped by better algorithms. It will also be shaped by whoever can generate enough electricity to power them. Because AI may be digital, but its cost is entirely physical. Thank you so much for watching. If you enjoyed the video, please subscribe and make sure to leave a comment below. See you in the next video. Stay curious.